Bismillahirrahmanirrahim. Today our topic of discussion is the Pauli exclusion principle. According to this principle, no two electrons in an atom has the same set of four quantum numbers. As we all know that there are four quantum numbers. One is the principal quantum number. One is the azimuthal quantum number. Magnetic quantum number. And spin quantum number. All of these quantum numbers, the first three quantum number, that is the principal quantum number, azimuthal quantum number and magnetic quantum number, these are derived from the very famous equation which is called the Schrodinger equation, and the spin quantum number is not from that equation. The principal quantum number is denoted by n, which is the 2n square. Azimuthal quantum number denoted by L, magnetic quantum number by M, and spin quantum number by S. So n power k is 1, L power the subshell, so power S subshell L is 0, power P 1, D 2, and F 3. Magnetic quantum number, which is extended from minus M to plus M for any of the S, P, D and F. And spin quantum number, on which the Pauli exclusion principle is based. There are two types of spin, that is the electron can spin on its own axis, and plus half spin, and minus half spin. This is the clockwise spin, and this is anti-clockwise spin. So M for example, M magnetic quantum number for the P subshell. P is L for the P is 1. So extend this L value from minus L to plus L, that is minus M to plus M. So 1, minus 1, 0 and plus 1, that is the P orbital composed of 3 orbitals. Actually, we will discuss these quantum numbers and details in the upcoming lectures, but now we have to find Pauli exclusion principle. For example, an atom with the electronic configuration of 2p5. So let's consider for the fifth electron we have to find a spin, and for the fourth also. So let's see what happened. That is the p orbitals, p subshell 1, 2, 3, 4 and 5. This is the fifth electron. This is minus 1, this is 0, this is plus 1. The electron of interest is the fifth one according to the Hund's rule. So if we looked here, this is n. N is 2. P for P, L is 1. So L is equal to 1. Now if we looked to this, the electron is in the 0 orientation, so magnetic quantum number for this electron is 0. But if we look to the spin, this is the minus half spin, that is the S for this electron is minus half. These are the 4 set of quantum numbers which are different for these one electron. All are different. So this obey the Pauli exclusion principle, and this is Pauli exclusion principle. For more information, let take this electron, the another electron, the 2p4 electron. So n is the same 2, L is also the same 1, M is